tectonic waves. Introduction. In the classical seismology, seismic waves are defined as waves of energy that travel through the Earth's layers, as a result of natural processes like earthquakes, volcanic eruptions, magma movements, large landslides, or man-made events like explosions, that generate low-frequency acoustic energy. Their velocity ranges between 4,000 meters per second and 6,000 meters per second. In the second half of the 20th century, many seismologists have come to the conclusions that another type of waves possibly exists in the Earth's crust, traveling at much lower velocities. These waves were called tectonic waves or strain waves, and were hypothesized based on the earthquake migrations and their distribution. The existence of the tectonic waves was finally confirmed by the omega theory in the year 2018, where these waves represent one of the most important theoretical concepts. Theory of tectonic waves. The classical concept of the seismic waves is based on the Cauchy continuum theory, which leads to the standard wave equation. In contrast, the concept of the tectonic waves is based on the generalized Kosárat continuum theory, which leads to the extended wave equation, or the so-called sine-Gordon equation. The Kosárat approach is used to describe slow faulting-related deformation of rock, where blocks of rocks between the fault planes can both translate and rotate. Such rotations are commonly observed by structural geologists between parallel neighboring faults. The best-known solutions of the sine-Gordon equations are kink and anti-kink waves, and breathers. The velocity of the tectonic waves is given by the Jurchenson-Bikov-Bambakides (GBB) equation and depends on the velocity of the moving tectonic plates considered, shear modulus of the rock, and stress associated with faulting and fracturing. Tectonic waves in the Earth's crust. The omega theory showed that tectonic waves trigger series of earthquakes in the seismically active and unstable tectonic zones, such as the edges of tectonic plates. Computer can easily resolve the directions and velocities of thousands of tectonic waves worldwide, based on the distribution of past earthquakes. Tectonic waves are where the earthquakes are. Therefore, extrapolating the position of the tectonic wave into the future allows us to create earthquake forecasts. What causes the tectonic waves? Statistical analysis of the earthquake distributions shows that tectonic waves travel with wide range of velocities. Some are extremely slow, a few kilometers per day, but faster tectonic waves can have velocities up to 6 kilometers per second. Statistical analysis also shows that tectonic zones and tectonic plate boundaries are among the most important emitters of the tectonic waves on Earth. Subduction zones emit most tectonic waves in two directions, in perpendicular direction away from the subduction, and in parallel direction to the subduction. Mid-ocean ridges are far more complex emitters. They emit tectonic waves in four directions. In perpendicular direction to transform faults, in perpendicular direction to ridge segments, and in two conjugate directions at the angle 45 degrees with respect to both transform faults and ridge segments. Nevertheless, everywhere on Earth one direction of the tectonic waves propagation is clearly the most important, and that is the north-south direction. A vast majority of tectonic waves travel exactly toward the north or south. These tectonic waves reveal that Earth's daily rotation plays the primary role in the generation of tectonic waves. In the light of the modern polarized plate tectonics theory, the driving mechanism of the global plate tectonics is the gravitational field of the Moon, which slightly changes the shape of the Earth due to tidal forces. However, the Earth rotates daily in the eastward direction, therefore, the tidal bulges of the Earth are slightly displaced with respect to the line connecting the centers of the Earth and the Moon. Due to the Moon's attraction, this creates westward torque on the Earth's lithosphere, which drives the tectonic plates for 0.15 mm per day toward the west. This deformation is the largest near equator, and the smallest near poles. The Earth's lithosphere is thus subjected to a daily shearing, which is partially released in the form of the tectonic waves. Conclusions. Tectonic waves are a theoretical concept developed by seismologists and physicists in the second half of the 20th century. This concept has gained on importance within the omega theory, based on which we can finally monitor these waves and their direct impact on the global seismic activity of the Earth. Tectonic waves can thus be used to forecast future earthquakes,